November 15th, period 7. We're learning about the difference of two squares today. So we are going to just find the page in our notes that has a list of all of the factoring methods, and next to difference of two squares, we're going to write down two terms. We're using this method when we have polynomials with two terms. All right, so here I've got a formula, write down the formula, and I've got our first problem. So the first thing we have to do is determine if the difference of two squares formula applies to the problem we're looking at. So in order for that to work, both terms, it has to be two terms, both terms have to be perfect squares. So I'm going to ask you, is 9 a perfect square?
No.
3. 3 times 3 equals 9, so yes, 9 is a perfect square.
Oh, yeah.
How about x squared? Is that a perfect square?
Yes.
It is. What can we multiply by itself to give me x squared?
1. X.
X. X. X times x is x squared. It is a perfect square.
You should know we don't raise.
How about 25? Is 25 a perfect square?
Yes.
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 So, if both terms are perfect squares and it is a difference means subtract, right? It has to be a subtract. If all of that is true, then you can use this formula to factor it. Okay? So here's how you do that. Remember, I'm unfoiling just like I did in the other methods we did recently. And my first times first is going to be the square root of the first term. So what's the square root of 9x squared? 3x. So 3x times 3x is my first times first. And what's the square root of 25? 5. So my last times last is 5 times 5. One gets a minus, the other one gets a plus. That's it. That's factored.
Yo, this is easy.
It is. This is one of the easiest, nicest factor methods. Where are you going? Yeah. Yes. Can you try that one for me?
Oh, I was right. Oh, yeah, that's a small R.
I did okay? No complaints. There's my next problem.
Oh,
Write that down.
Oh, shucks. Wait, in there like swimwear.
What's the square root of a to the 4th?
A to the second.
A to the 2nd. So that's my first times first.
Okay, Diamond.
What's the square root of b to the 4th? B squared. B to the 2nd. So it's last times last. 1 minus 1 plus. But I'm not done.
Oh, no.
Okay. So, just like when we, with some of our problems in the past, we did a GCF, and I said, well, you have to check the parentheses to see if the stuff in the parentheses is factorable. Well, that's true.
Please excuse this interruption.
All right, so you have to check your parentheses to see if anything in the parentheses can be factored. So let's take a look at the first parentheses here. Can you factor what's in the first parentheses?
Yes.
Yes, you can, because it's the difference of two squares. So let's factor that again. So what's the square root of a squared? A. And the square root of b squared is?
B.
1 minus 1 plus. Can I factor a squared plus b squared?
No.
No. Good answer. Why?
Big X.
Because?
X.
Because it is not a difference. So in order to use the difference of two squares, it has to be a subtract. Pluses cannot be factored. So bring it down. And that's it. That's factored as much as it can be factored.
So you can only factor it when it's negative? When it's
Yes.
minus?
Is my mustache?
All right, try that one. All right, how did I do? What?
Not good.
No, what did I do wrong?
You got too many parentheses, that's about it.
I got too many what?
Parentheses, like, ain't the third one not supposed to be there?
A to the,
It
what?
can't be, like.
All right, so first thing I did was,
Wait.
go ahead.
No, never mind. I don't know.
So the first thing I did was I used the difference of two squares, and I have now my two parentheses. And then just like the previous problem, the first of those parentheses, again, is the difference of two squares. Both terms in there are perfect squares, and it is a difference. So that's why I used that formula again to factor that out further. The sum cannot be factored. Now it is not factorable any further. None of those that are left are the difference of squares. What do you always do first?
GCF.
GCF, good. So, what's the GCF of this? 3. I'm going to divide 3 out first. So 3x squared divided by 3, x squared, negative 27 divided by 3 is negative 9. So I'm looking at my parentheses. Is my parentheses factorable? Yes, that's the difference of two squares. So I've got x minus 3 times x plus 3. Write that one down.
Oh my god.
It looks scary, doesn't it?
Yes.
A little bit.
Hold on.
What's the GCF?
Next.
So 50a squared b divided by 2b is 25a squared. Negative 72b divided by 2b is negative 36. Is the parentheses the difference of two squares?
Yeah.
Yes.
Yes, it is. And the square root of 25a squared is 5a. And the square root of 36